Good morning, everybody, and thank you very much for joining this Yewno technical webinar. A warm welcome to you wherever you are in the world. So in fact, it's maybe not the morning, so good afternoon or good evening as well. In terms of what we're going to cover, this webinar is very specifically going to talk about the blend of artificial intelligence that we use at Yewno and how it can help researchers, librarians, and content owners or publishers. And we're going to look at full text search and how AI has enabled that in terms of the ability now of algorithms to actually read and not just hunt for keywords, but actually understand context in the unstructured text that they're reading, and how that can also benefit researchers in terms of being able to find exactly what they're looking for and save some of the frustrations that have been prevalent in traditional research tools, how it can help people curate collections, and some of the implications for scholarly publishing in terms of the ability to surface items of content that might historically never have surfaced in relevant results. And also looking at where we are today, why is this important in a digital, socially distanced world? You know, as we're all unable to attend events, we're not able to get advice from somebody in the library, how can this AI technology actually help overcome some of those things? There will be a chance for questions at the end, but also do feel free to send questions at any time in the QA channel. So in terms of the agenda specifically, we're going to start off by looking at the ecosystem today and how new tools can fit into that and enhance and complement what's available already. Then I'm going to go into a little bit of a deep dive in terms of the specific artificial intelligence technology that we use at Yewno, looking first of all at knowledge graphs, looking at our concept approach, disambiguation, and how this can help us deal with the way that language evolves. Then we're going to look at full text search and how AI can really help in terms of unearthing certain things that might have been not discovered in a more traditional cataloging approach. Then I've got a use case about some specific content that would never have been cataloged, but that's very, very relevant to a specific search. Then we'll summarize and I'll take you through some frequently asked questions. So first of all, looking at the ecosystem today. So in terms of where we are with traditional search tools, those tools are really, really great if you go to a search bar and you know what you're looking for. If you know the author, the title, the publisher, you should be able to find the exact item of content you're looking for really, really quickly. But if you're less familiar with the subject, if you're not entirely sure of the relevant terms or how to formulate your search query, and if you're not sure in the first place which the best search tool might be to go to, discovery can really help there. So it's really designed for people who don't necessarily know exactly what they're looking for. They don't already know the exact content item. They're more in that exploratory or discovery phase. So if you have complex questions or open-ended questions, if you're not totally familiar with the landscape, or if you're looking to put something into context, what's brilliant about an AI-based discovery tool is that it can help you with things that haven't historically been available. So things like graph visualization to show not only concepts, but how they connect, and also to give you ideas of things you wouldn't necessarily know were connected to your search. So in terms of what this gives us, it really gives us the opportunity to provide a different perspective on information. So in the next section, I'm going to go through this in a little bit more detail, but essentially what artificial intelligence algorithms can do is they can take unstructured text and read all of the text, every single line, every single sentence, and then translate that into an enormous knowledge graph, which gives us this fantastic discovery environment, which is not just like a traditional database, which stores items. It's a dynamic environment where things have connections, and those connections are always maintained, always current, always constant. And it can deal with things like the ambiguity of language, the evolution of language, and disambiguation. So that's just a little bit about how it can fit into the existing ecosystem and complement some of the tools we already have available. So next, I'm going to look at AI technology in a little bit more detail, really specifically focusing on knowledge graphs and some of the components of those, such as concepts, disambiguation, and the evolution of language. So going into this in a little bit more detail. So what you see on the left-hand side here is content, and it can be any kind of content or information. It could be a news article, it could be a patent or a clinical trial, it could be a journal abstract, the full journal article, a book chapter, a dissertation, and so on. And the key thing about this is, because it's a machine learning approach, Volume doesn't matter. So you can ingest as much content as is created on any day. And we all know that the amount of content that exists today is completely overwhelming, and it continues to grow on an enormous scale on a daily basis. So it's way beyond the powers of any human to read and interpret it. So what you have in the middle is a series of artificial intelligence-based algorithms that are looking to recreate a neural network model. And when I say recreate a neural network model, what I mean is they're trying to recreate the way in which a human would read and interpret the text. So as the algorithms read, they are looking for meaning, and they're interpreting and identifying meaning and then turning that into concepts and promoting those in a knowledge graph, which you see on the right. So the great thing about a knowledge graph is that it's a fantastically flexible mathematical instrument. And all of us on this webinar could be looking for something different. And in the knowledge graph, we can find exactly what we're after, a fully disambiguated term, and we can also find all of the things it's connected to. And depending on our level of research and how experienced we are in that subject, there will be some things that you were expecting to find, but you will always find unexpected things that you didn't necessarily know to look for at the beginning of your search. Because the knowledge graph has all of the obvious connections that you might already know, but it will also make non-obvious connections. And that's because of the scale at which AI technology can read way, way more content than any of us humans could possibly do. So I want to show you now a little diagram, and you're going to see here the lines on this chart are moving. So what I'm showing you here is news being ingested real time into a knowledge graph. And it's about 9,000 items of news that are being ingested every day over the time period that you're looking at here. And what it's showing us is really two concepts, tariffs and trade wars. And it's showing how the relationship of those things is changing over time. And this is just to give a sense of how important it is to have a dynamic environment to store all of our content in. So if you have a static environment where language evolves and terms are not updated, or where there are gaps in cataloging or indexing and things are being missed in the first place, that's not going to work as things move and as relationships change and as things that were not connected become connected and as the importance of connections might go up or down. And you can see here, as you see the bars move in real time, that the connections are changing, and the dynamic environment is really the only way of being able to keep up to date from a research perspective. So looking at Yewno's approach and how we are able to provide this dynamic environment, keep information up to date, and provide a completely different way of researching using artificial intelligence, it's a concept-based approach. And the key thing about a concept is that it's not just a word or a group of words, but it's paired with a definition, and it has a significance, and it also carries with it inference. So there's everything you know because you can read about it, and the text has those connections. But in a knowledge graph, the knowledge graph itself can infer connections. Using its multidimensional semantic vector space, it can identify where there's a proximity that none of us with a human eye will be able to see, and it can infer that there might be a likely link. So it adds that new dimension into the research ecosystem. So let's start off by taking a little bit of a look at what exactly is a concept. So a concept you can think of as a keyword, but it's much, much richer. So if you look here on the left-hand side, we see a picture of Jaguar the animal. And on the right-hand side, we see a picture of Jaguar the automobile. So the same word, Jaguar, is used for both. But in the world of Yewno and in the world of our knowledge graph, each of those Jaguars is paired with a definition. So on the left-hand side, we can see Jaguar is the largest cat in the Americas, and we can see it's in the topic of nature and the subtopic of zoology or wildlife. And on the right-hand side, we can see Jaguar is the luxury vehicle brand of Jaguar Land Rover in the topic of engineering and cars or marketing and brands. So two completely different things, but actually using the same term. So the fact that you're able to actually attach a definition to the word or group of words gives you that level of accuracy when you're searching in terms of being able to find and surface only the relevant items. So how does the technology actually identify these concepts from the text and promote them into the knowledge graph? So what you see on the left-hand side is a piece of text from a document. Quantitative easing is a type of monetary policy used by central banks to stimulate the economy when standard monetary policy has become ineffective. So you can see here highlighted in purple that the technology has identified monetary policy is a concept, is a potential term. So it extracts that concept and it promotes it. And then you see we have as a candidate concept monetary policy. So what the technology will then do is it will say, is this a valid term? It will look for a lookup. It will look for a reference description. So at Yewno, we don't write descriptions for terms. We always use a reputable reference source. And it's looked in the knowledge base and it's found this description that monetary policy is the process by which the monetary authority of a country controls the supply of money. So that's a valid description. It matches the term and it can then be promoted and become a concept in the knowledge graph. So you can't just randomly add terms to the knowledge graph. They have to go through a process of promotion and validation, and they have to be matched with a definition. So why is this really, really important? So actually the ability of the technology to disambiguate is critical in terms of people finding the results they're after. So if, for example, you went to a search bar and you put in the word depression, you might be looking for depression in geology. You might also be looking for a low pressure area in meteorology, or alternatively, you might be looking for depression in economics. And if you were interested in economic depression, you could be thinking about the Great Depression, the Long Depression, or the Depression of 1920-21. Alternatively, you could be looking at something completely different. You might be looking for depression, the mood, or depression in physiology, or something like a major depressive disorder. And I'm sure you've got the point here. I could go on for at least another page of all of the different types of depression. So some traditional search tools will take your previous behavior and they'll say, well, last time you put depression in the search bar, you were looking for an economic depression, and they will surface all of those results. But what if in this time you're doing a totally different course and you're actually looking for depression in the mood, for example? So what's great about the technology is that it won't just guess what it thinks the user's after. It will actually offer a series of terms and disambiguations, and you can choose and you can say, this is the kind of depression I'm after, and then you'll get an incredibly accurate results list based on that search term. The other great thing about artificial intelligence technology today is that the algorithms are reading the full text, and they're not just hunting for keywords in the way that NLP does. They're actually reading the text and understanding the context and its meaning. So if you look here at these two sections of text on this chart, on the left-hand side, we see routes to plastic models and prototypes using the SLS selective laser sintering process. And on the right, we see something from the American Society of Mechanical Engineers. And both those sections of text are actually talking about 3D printing, but the term 3D printing is not actually mentioned in the text. So in this way, artificial intelligence technology can surface pieces of text that would never have been found in a traditional search tool because the word isn't actually mentioned and it wouldn't have been indexed. In terms of another example, there's often hidden content missed. So if you look at something like the United Nations Sustainable Development Goals, they have particular wording or terminology applied to them. So the example on the left is showing us zero hunger. So the term zero hunger is not mentioned in either of the pieces of text here, but it's absolutely relevant and it's absolutely what they are about. On the right-hand side, we've got another United Nations Sustainable Development Goal, number 5, about gender equality. And again, many terms have been used in the past that are not exactly that term. So if a traditional search tool does an exact keyword search, you wouldn't have found this content. So because the artificial intelligence can understand the text as well, it's not just hunting for keywords, it can find things that would never be surfaced in a traditional environment. And also if traditional cataloging has potentially had something like bias, or maybe it's just lacking in granularity. Maybe the person who cataloged at the time was only looking for 10 keywords. They might just have missed something because it couldn't possibly, when being done by a human, cover the entire article in the same level of granularity as is possible with AI-based indexing. So now I'm going to take a little bit of a look about how we do full text search. And it's an absolutely transparent approach. And the great thing about it is that because the algorithms are reading the full text, they are able to take the user, the researcher, the publisher, the content owner back to the exact section of the text that they're looking for. So they're not simply finding an item of text and then saying, here you go, read the whole thing. They can actually take you to the section of the text which has the part that you're looking for in it. So looking here at how content is processed. So on the left-hand side, content is ingested into the pipeline. And as we showed on the earlier diagram, it could be any type of unstructured text. It could be anything from a journal abstract to a full journal article, a book chapter, a piece of news, a patent, and so on. So the full text is ingested and is being read algorithmically end to end. And then what our pipeline does is, the first thing it does is to start to split the raw unstructured text into what we call text snippets. So a snippet is a section of text. And the key thing about this is that through splitting the text into snippets, you're able to take somebody back to the exact section of text that they're interested in. So that's super useful in terms of the end product. And then what the algorithms do is they perform concept extraction on each snippet of text. And each concept extracted will have a range of different rankings. So if you look here, we have two concepts we're showing from this tiny piece of text. The first one is dividend. And you can see that for dividend, we have what we call a concept ID, so an identifier. So if, for example, the term dividend had multiple different meanings, the concept ID is the thing that would enable us to understand which kind of dividend and what reference definition is associated with that word dividend, and help somebody find the correct answer. And then you can see we have a pertinence score. So every concept will always have a score, again, to tell us the importance of that particular concept. And then the second concept we have here, cash flow, again, it has a concept ID in case there is a potential other meaning. And again, it has a pertinence score. So taking a look, so this is the piece of text, and it's quite a small, short piece of text. It's actually news, but you can see how many concepts have been extracted. And if you think out to what that might look like in a book you might have many hundred, even thousands of concepts going down to this incredibly granular level at a paragraph. So the concepts here, we can see we've got everything from single word concepts like uncertainty and investor, to double word concepts like Great Recession and precious metal, and even things like silver as an investment and Chicago Board Options Exchange. And all of those concepts have a definition associated with them. And you can see here, we have on the left, the concept ID for disambiguation. Then you have the term itself, the word or group of words, and then you have the score. So I'm going to take you now into a little use case of something that I was researching about the spy diaries, and how the technology was able to find content that hadn't historically been tagged using a traditional methodology. So there was some really interesting things published in the news recently about some information that has been embargoed for 75 years since the Second World War, but that has just come into the public domain. So new documents were released about the birth of a secret intelligence pact between the US and the UK 75 years ago. And on the left-hand side is the actual diary that they were releasing, and you can see all of those handwritten notes. And it says a short entry from February 1941 in the diary of Alistair Denniston, released for the first time today by GCHQ, marked the beginning of what was once the most secret of relationships. So I've always been intrigued by espionage and things like that, so I wanted to investigate further. So I thought I would use Discover and take a little look at Alistair Denniston and who he was and how he fitted into this picture. So first of all, starting a search, you can see Alistair Denniston in the middle, and you can see his many, many connections. So we know he was part of the Second World War cryptanalytics, because that's what the article told us. And then here you can see all kinds of other connections, many things that you probably could guess, like a connection to Alan Turing, if he was working in the Second World War cryptanalytics. And you can see things like the Enigma machine. But there are many, many things here. Some of the concepts are people and names, and some of them are places like Bletchley Park, but a huge number of things, not all of which I actually knew about beforehand. So looking further, if I was interested to find some actual documentations that was written about this guy, Alistair Denniston. So I took a look and I found some really, really interesting things. There was a book by Stanford University Press, an article from the Jewish Historical Society of England, and quite a lot of things from Sage. So I thought I would go and say, could I have found those using a traditional search approach? So I started off at the Stanford University Press website. And as you can see on the top right, I put in the term Alistair Denniston. And actually what I got was this book here, New Directions in the Study of China's Foreign Policy. And the reason I got it was because the author's first name was Alistair. It's not actually a book about Alistair Denniston from the Second World War that I was looking for. So that's not that surprising, because if we look at the detail about what was published in the book about Alistair Denniston that I had found in Yewno Discover, it was just on the right-hand side. You can see it was a single paragraph of text that mentions him. So when somebody's cataloguing a book, they would never have chosen him, because he certainly wouldn't have been one of the top 10 or top 20 concepts. So that meant that you would be unable to find this book in a publisher website. You'd be highly unlikely to find it in any kind of traditional search tool, but it's very, very relevant to a search that you might be doing if you were interested in investigating this guy, Alistair Denniston, and specifically what happened in the new release of the Spy Diaries. So here we can see that if you compare an AI-based approach to a traditional approach, you would certainly never be able to find something that was tagged in one paragraph of a book. But it was highly relevant for the researcher with no chance of being found, and also highly relevant for the publisher to be able to know that they had the content in the first place. So I'm going to summarize today, and then I'm going to move on to some frequently asked questions. So in terms of what does AI really offer to all of us in the sort of library, publisher, content owner, research space? First of all, it offers an entirely new way to explore, partly to do with a visual interface. So historically, we have simply not been able to create this kind of visual interface where you can actually see concepts and their connections. And what's so amazing about it is that actually seeing how any concept can relate in context is critical to learning and understanding. It's also brilliant in terms of giving you ideas of how things might connect. And really what it can do is capture the imagination. So we're all very familiar with lists of search results because that's what we've been using for decades. And that's the best way that technology historically has been able to provide access to information. But now we can go that stage further, where the algorithms are not just giving you a list, which could be a particularly long list as more and more content is available, but the algorithms can actually read the text and they can identify the concepts, and they can help you to read through these thousands and thousands or millions of items that none of us as humans could. And then they can give us this visualization that enables us to go straight to the point and dive straight into the relevant content. It's brilliant for interdisciplinary research because there are situations in traditional research where people curate collections and they are absolutely fantastic and incredibly rich on one subject area, but they are limited to a specific subject area. And great discovery in the future will in part come from the intersection of domains of information. So if you are using a traditional tool that limits you to one domain, you won't have that opportunity for any kind of interdisciplinary discovery. The other thing is that in traditional tools, you do lose a little bit of serendipity. So that experience when you might have walked into a library or a bookshop and you might just have stumbled across something, or you might have been looking for something and found something next to it that you had not been looking for at all in the first place, but actually it grabs your attention and it's relevant to you. And so what the knowledge graph visualization is brilliant for is in showing you things that are unexpected, that maybe weren't the start of your search, but actually they can be very interesting and potentially relevant in terms of where your research journey is going. It can also be used to hypothesize. So as humans, we all have intuition. So you might have an intuition that two concepts are connected, but you actually don't have any literature to support that. So what you can do is use the knowledge graph to put in different connections. So here you can see in the picture on the right, we've got developmental robotics and psychology. And we're able, the knowledge graph has visualized for us the things that connect those two. So two different domains of information that do indeed have connections. And using this approach also, because it gives you so much richness in terms of connections, it can help formulate search queries, and it's great for teaching and learning. In terms of further possibilities, it also really helps us all to discover hidden content. So all of the content that might not have been tagged using a traditional historic approach done by humans. And it also helps us overcome some of the barriers. So potentially we have biased results simply because item has been tagged by different people who've had different perspectives. Maybe there are terms that people didn't want to tag in the past to do with bias. But fundamentally, I think the biggest problem is really just about the level of granularity. Historic tagging just hasn't been able to give the granularity that you can get from an AI-based approach where algorithms are reading the full text and they're able to tag every relevant concept from that text. And disambiguation is another key point. So we looked at the word depression earlier. And again, when someone puts depression in a search bar, there could be so many different meanings. And you don't want to get a results list cutting across all the different things. You want to be clear on the kind of word you're looking for and get the results relevant to that specific search term. And as I showed earlier, because the technology has read the full text and because it can break it into snippets, it can then take the researcher, the user, back to the exact section of text that they're looking for. So I was very interested a couple of years ago, somebody at Frankfurt Book Fair said to me, how many people do you think read more than halfway through a journal article? Not a trick question. And they said it was less than 5%. So the way in which we all engage with information and digest information has changed dramatically over the past decade or two with the advent of all of these smart devices. So people expect to find what they're looking for and they don't have huge attention spans. And what AI can do is help people find what they're looking for and really move away from one of the biggest frustrations of research historically, which has been searching and not finding what you're looking for. So it can keep people engaged in the research process for longer because they are more successful in finding what they're looking for. And overall, having a visual environment is just much, much more engaging. So I've got a couple of frequently asked questions. So I'll kick off the QA here and I'll go through those and then I'll pick up anything that people send in on the QA channel. So do please feel free to send anything you would like to discuss into the QA. But starting off, in terms of frequently asked questions that I often get asked, people often ask me about the difference between graph visualization versus knowledge graph technology. So today we do often see pictures of sort of a visualization that looks like a knowledge graph. So I think the key difference between the visualization of a database versus an actual knowledge graph is that many of the visualizations you see might be manually created. So I would say the first question is, how many concepts would it have? And if you're in the range of sort of 3, 4, 5,000, even 10,000, that's probably got some kind of level of manual curation. So it's not scalable. So in our knowledge graph, we have over 5.5 million concepts. And the only way that you can possibly deal with the volume of information today is using a machine learning approach. The other thing to be clear about is the visualization you're looking at, is that based on the existing traditional metadata? Because we all know that metadata is incredibly varied across different publisher types, different decades, different types of content. So if that's your starting point, you cannot possibly be surfacing information equally in an unbiased approach. So I think the key difference between just a pure visualization versus an actual knowledge graph is that knowledge graph technology enables us to keep information up to date dynamically. So as new information is added, it can be linked in and connections and the strength of connections can change. It shouldn't need human involvement. There might be a small amount of human involvement, but mostly it will be a machine learning approach, which means it's infinitely scalable. The next thing is that the terminology, so language does evolve. And today in 2021, we are using different terms than we were 5 or 10 years ago, and certainly 30, 40, 50 years ago, and hundreds of years ago. So to give an example, the illness we call malaria today, Captain Cook sailors called tertian fever. So if you put in tertian fever, you would not be finding items about malaria and vice versa. But actually the illness is the same illness, it's just a different word that we're using today. So if you have a technology that can understand that the concept is in fact exactly the same concept, and it can do that because there's a definition, it doesn't matter if the word changes over time. And that's particularly important as we look at things like diversity, equity, and inclusion, where terminology has changed. A lot of it is terminology that we would not want to use today, that we would not feel comfortable using today. But actually you do want that historic content to be surfaced because from a research perspective, it's historically valuable. And we looked at some examples earlier in this pack around the United Nations Sustainable Development Goals. And again, those specific terms were not necessarily used throughout history. So there's relevant content that might not be surfaced. So we also looked at some examples of how reading the full text algorithmically can help surface hidden content. And all of us have content collections, whether you're a content owner or whether you license content, you want to get the most value out of that content. So the ability of a new technology that will actually have tagged more items and be able to surface them more accurately is great. And I think finally, the most important thing is, as a researcher, you want something that's going to give you a consistent approach. You don't want certain types of content to be surfaced simply because, you know, they were tagged better. You want it to be based on actually the relevance to your search. So another question I get asked all the time is, what kind of content can we include in our knowledge graph? So the first point is, it does have to be digitized content. So if there's any print copy, that is not something that our technology could deal with. I also often get asked about foreign languages. So we deal mostly in English, but where we do have foreign language content, we've been testing over the past couple of years the use of Google Translate. It has changed dramatically, I would say, in the past 5 years. If people are interested, I'm very happy to talk about that in a bit more detail. So do feel free to email me. We would use Google Translate to translate it, and then we would use it in English. But if you look at the list and you don't see anything, let me know, because it's possible that it would be usable. And then what about poor quality digitization? So some of the earlier digitization is not necessarily brilliant, but actually redigitizing is obviously a very, very expensive avenue or approach. So one of the good things about AI technology, because it's reading the full text and because it's dividing it into snippets, it can simply ignore the elements that are corrupted text, and it can use the bits that aren't corrupted. So if, for example, you have an archive with a big range of mixed quality, you don't actually want to spend weeks or months wading your way through thousands or even millions of items to say which are high quality and which aren't, but they can be read algorithmically. The bits that are corrupted will be discarded, and you can have a percentage completion rate for each item. So then as a content owner, you can decide which bits you do or don't want to either redigitize or potentially to retype. So the benefit is that you can it saves you through sorting through absolutely thousands or millions of items, and then the bits that can be used will be used. So if people do have further questions, do always feel free to email in. And we do have a couple of questions here. So one of them is, how is Yewno different from Microsoft Academic, Open Knowledge, or Dimensions, and other AI-based search or semantic engines? So first of all, thank you very much for that question. What I would say is everybody is using a slightly different blend of AI, and they're all doing different things. So Dimensions is a fantastic product, much more aimed at a research office, using a slightly different content set and a slightly different algorithmic approach. It does have a lot of information about things like grants. Microsoft Academic, we actually use some of their content. So we actually use the journal abstracts as one of the inputs into our knowledge graph, but it's not analyzing them in the same way that we do. I'd have to look at the third source that you mentioned. Then another question, how do you deal with ontologies and control vocabulary? So I think the key thing for us is that we use a lot of different reference types. So we do use things like Mesh, we use things like Investopedia, Wikipedia. So we always have an open source definition for any concept. But we are going to read the full text. So we don't have to rely on something like a control vocabulary or an ontology that was created in the past. So the key thing is that all of the definitions are from reputable reference sources, and you can find them using that kind of terminology. So we don't have any other questions for now. So I would like to thank everybody for attending, and anybody who's registered is going to be sent a copy of the recording. Have a great rest of the day, everybody. And as I said earlier, feel free, if you would like to send in any other questions after the webinar. Thanks for joining.